So we have a few questions for you. One is what's the reason not to trim down to a closer number, like 1.25 or 1.5 of the wanted crop load? Why do you have such a large buffer in there?
That's based on the research that we've done so far at Geneva, and we've now repeating it in the Champlain Valley, that when we prune closer to 1-to-1, we got too large of fruits and we didn't get return bloom because there was no resting spurs. We did a separate study where we looked at whether you have to have resting spurs with this variety, and you do. When we prune to 1.8, we hope we can knock off all the fruits on the extra spurs so that they become resting. Plus the tree produces a few new spurs every year that will flower, and that tends to give us the best combination. If we leave too many spurs, there's just too much gibberellin and we can't ever overcome it.
Okay, I think this is sort of on the same track. So the question is that someone prunes to the right number of buds on Gala to make them large tray apples. Their Honeycrisp are already too big. If they prune to the correct number of buds on Honeycrisp, why won't that make them bigger the same way it does with the Gala?
So with Gala, we have a lower target for buds. We want 1.5, and some growers are even more aggressive, pruning down to 1.2 buds. And what that does, it does give more resources to produce larger Galas. So Honeycrisp has been a challenge in that we don't want the fruit too big. If we leave more buds, we keep the fruit smaller, but we don't get return bloom. So this 1.8 is sort of a balance between having too many buds and too much gibberellin and no repeat bloom, and then pruning too severely and getting too big a fruit.
Okay, great. Yeah, that makes a lot of sense. Another question, if it were legal, what is a lime sulfur oil spray rate?
I want to be clear, if it were legal, because it's not. So we have used 2.5% lime sulfur and 2% oil. So it's 2.5 and 2. First is lime sulfur, it's a little bit higher, 2.5, and then 2% oil. We've used a variety of oils. Fish oil seems to work excellent, and that's what organic growers use. But we've tested soybean oil, we've tested spray oil, and they work almost as good as fish oil. So I just recommend either a dormant spray oil or ultrafine summer oil.
Okay, another question.
Well, I don't recommend either one of them because they're not legal.
Right, duly noted. So a question about, given sort of the variability with some of the king blooms being frosted out, this question is asking whether you would consider finishing off the rest of the king blooms using an ATS or LSO before they pollinate, and then try to crop out the laterals in order to reduce some of the variability in crop load this spring.
Yeah, that's, I think, a possible solution, but it's risky. And I would be very worried that we would somehow knock off the king and the laterals that we need. So I would prefer to skip blossom thinning where we've lost most of the kings, and then come in at petal fall with a better assessment and then 10 millimeters. Because if we've lost the kings, we've lost all those seeds. And there's a huge amount of gibberellin that comes from the king seeds, even more so than the laterals. And it's the amount of gibberellin that these total number of seeds on the tree are producing that inhibits return bloom.
Okay, thanks. And how about the timing on pollen tube growth model for LSO?
If it were legal and if I were recommending it, then we prefer to go close to the 100% on the pollen tube growth model, 90 to 100%. Now, it's really difficult because sometimes that's at 11 at night, or if it's 2 in the morning. So just sort of somewhere above 80% is good for me. But if you go past 100%, you allow too many other flowers to be fertilized and you get very little response. The problem with ATS is if we go to 100%, we get almost no response because too many flowers are pollinized or fertilized.
Okay, so we have a question here for Art, if Art is there and ready to answer, asking about the efficacy of the coddling moth isomate tube dispensers compared with low density dispensers, or maybe just more broadly, sort of if you could compare, contrast some of those mating disruption options.
Yeah, so the sidetrack meso dispensers, I will say that we have not worked with them. We have not tested them ourselves personally in New York, at least not in our research orchards. But in speaking with colleagues in Michigan and Pennsylvania, they say that the general level of disruption they provide is comparable to the twin tube, twist type dispensers. Probably you get a little bit better shutdown with the twin tubes, but certainly it's very acceptable using those meso dispensers. So that's as much as I'm able to say about it.
Okay, great, thanks. Back over to Terence. Question, would hormonal thinners be a good option during bloom where there is some frost damage? Does that seem like a good option?
Yes. So in the past, we've suggested NAA at bloom, 10 parts per million, as a way to get started to reduce the seed number and avoid return bloom problems. I would say that if it's a question of whether or not to spray any ATS at bloom, possibly 7.5 parts or 5 parts of NAA would be a good option to help induce good flowering for the next year.
How about someone asked if I had an ATS in a drum outside from last year, is it still any good to use?
As long as it hasn't salted out, it's still good to use. It's a salt, it's ammonium thiosulfate, and it can salt out. And so one way to look at that is if there's any precipitate in the bottom of the barrel. If there is, it's no good. But if not, it's still good to use.
Okay, and what rate of calcium chloride would be applied at pre-harvest?
At pre-harvest, for calcium chloride is 3 to 4 pounds of calcium chloride per 100 gallons of water.
Okay, perfect. And another question that could be either Terence or Lailiang might jump in on, suppose there's a branch on a Honeycrisp tree that is blank. Are we better off removing it and renewing or leaving it on? Which option will cause more problems for bitter pit by drawing the calcium from the new growth?
Well, let me tackle the first part and then Lailiang can tackle the bitter pit issues. So in terms of a branch that's blanked out and has no flower clusters, if we remove it, it depends upon the total number of other flower clusters on the tree. If we already were excessive and we had like 3 times as many flower clusters, we would be removing the only buds that will be floral for next year, because all the ones that are flowering probably will have nothing. If we had pruned down to a precision number of 1.8 times the target number, and then we thinned early with blossom thinning, we wouldn't need those buds for next year. Now, the impact of those buds on bitter pit, I'll defer to Lailiang.
So because this branch, I completely agree with the Terence on whether or not to remove that. But as this branch does not have any flowers, is that right?
That is the question, yeah, if it's a completely blank branch.
Yeah, if it's a complete blank, no flowers, this removing it in terms of bitter pit management sort of only has a limited impact unless removing this branch significantly invigorate the trees. I mean, again, it's depending on how many flowers that are present on the rest of the tree. If removing this branch somehow, significantly invigorates the tree, yes, that may have increase the bitter pit risk. But if if overall, the tree is very calm, I don't think removing this would affect bitter pit that much.
Okay, great. And then we just have one more question at this point. So a reminder, if anybody else has questions, go ahead and put them in now. If not, we're going to wrap up pretty soon. But the last question that I have so far is, in terms of controlling the number of fruit buds per tree, what about suggestions for non-high density orchards? Would that be a similar suggestion for the larger trees, or do you have any other recommendations for those?
Yeah, for those trees that are not high density, tall spindle or super spindle, the same principle of limiting bud number, flowering bud number would apply. It just takes more effort to count a bigger tree. But you can work by branches on bigger trees, and there you could target a bud number of about 7.5 times the circumference or the square centimeters of the branch. We want 5 fruits, and so 1.8 of that would be somewhere around 7.5 or 8 flower buds per square centimeter of branch circumference. The best would be to count the whole tree, and then have your target for that tree, and multiply it by 1.8, and then reduce bud number to that. I want to add before we wrap up that I was reminded that there are at least 2 other chemicals that are registered for use during bloom. NAD, which is a very close relative of NAA, was labeled for use during bloom, and it works equally well as NAA. The last one is regalia, which is a organic approved product. Our results have been very mixed, I guess, with that product, where we have gotten very little thinning, but it is registered for blossom thinning.
Okay, great. So that, one more question just came in. They've been talking about front-loading calcium and then tapering off later. The new rec is to increase applications rate later in the season. Why the change in that recommendation?
Well, in terms of calcium, foliar calcium sprays, it's, people have argued that the earlier the better. However, if you think about the timing of calcium spray, if you apply calcium too early, the current recommendation is 7 to 10 days after petal fall, you start the spray. If you apply calcium too early, you run against 2 factors here. One is the earlier you apply the calcium chloride, the higher the phytotoxicity risk, because the foliage and the fruits are very tender, so you run a higher risk. And second, because it's only the calcium that gets sprayed onto the fruit surface that makes a difference. That has an opportunity to be taken up into the fruit. So if you apply it very early, the fruit surface is just too small, very, very small. So most of the calcium goes to the foliage, very little ends up on the fruit surface. So that's why the recommendation has been starting from 7 to 10 days after petal fall and start the spray. And then later in the season, 4 to 2 weeks before fruit harvest, you come in with the higher rates. At that time, the fruits and the foliage are more tolerant of phytotoxicity, and also the fruits have a larger surface to take up the calcium. So that's the justification. And Janet, I also want to add that in my discussions, I forgot to mention the other effects of excess nitrogen on bitter pit development. So the one effect I mentioned is that if you apply too much nitrogen, you invigorate, you make the trees too vigorous, and that draws most of the calcium to the shoots and leaves, leaving very little calcium for fruit. That's one effect. However, nitrogen has at least another effect. That is, when you apply too much nitrogen, you elevate the fruit nitrogen status to a high level. The fruits with high nitrogen respire more, so have higher respiration rates. That requires more calcium in the cell membranes, so further exacerbating the ratio between nitrogen and calcium. So that's another effect. You know, of course, you can think of a third effect of too much nitrogen is that when you apply too much nitrogen, the fruits tend to become bigger, so further diluting the calcium in the fruit. And also, I want to add my last point on the sap analysis, pure sap analysis. Based on the work we did over the last 3 years, in early July, pure sap samples are a potassium to calcium ratio around 23, 25 appears to be the threshold value. Above that, you make the bitter pit risk significantly higher. If you keep that ratio below, 23 to 25, that would be good for reducing bitter pit incidence. I think that's all I have.
I'd like to just wrap up, if I could, just for a minute.
Go ahead.
This is the whole package. We presented at the fruit school. It starts with precision pruning, continues with blossom thinning, which was iffy now because of the frost predicted and the frost we've had. But if we can get crop load right, it has to be followed up with this peel sap analysis in early July, and then a passive storage sample for bitter pit, so that when every lot of Honeycrisp comes to the storage, it has a passport information with it. What are the ratios of nitrogen to calcium, which should be 10 or less, and what is the ratio of potassium to calcium, should be less than 25. And that will allow us to store fruit in a better condition to determine whether it should be given preconditioning or not. I hope that things work out, that we can get every block adjusted to the right crop load early, either through blossom thinning or the frost. But then we follow it up with these nitrogen ratios and calcium ratios, and end up with fruit at this harvest season that we know what to do with it, and we can control bitter pit, and we'll still get repeat bloom next year. Thanks for your time and attention. I hope it's helpful. Have a good day.
Great, thank you, Terence. Thanks everyone who presented and everybody who's been listening in today.